Welcome to the session of Hadoop Architecture. In this session, we will be discussing in-depth details about Hadoop Architecture. So, Hadoop or HDFS architecture. We also can say this as HDFS architecture. Now, after installing Hadoop in commodity machines, or after installing Hadoop on a single laptop or a desktop, now when you start up, the next thing we have to do is start the cluster. When you start Hadoop or Hadoop cluster, now you would be seeing 5 processes of Hadoop being run on your machine. 5 processes, or we also call them as 5 daemons. So 5 processes are different processes of Hadoop architecture, or different processes that run on HDFS. So one is name node, secondary name node, data node, job tracker, and task tracker. These are the 5 daemons you would see whenever you give a command on your console to start Hadoop. You would be seeing these 5 daemons or 5 processes running on your Hadoop cluster. Now let us discuss about each and every process in detail. What is the name node, what is the secondary name node, what is the data node, and what is a job tracker, and what is a task tracker. In another way of representing this is, as we have said, Hadoop architecture, the whole architecture of Hadoop follows a pattern called master and slave architecture. Master and slave architecture. So Hadoop is designed depending on master and slave architecture. So there would be some masters, and also there would be some slaves in Hadoop architecture. Now name node, secondary name node, and job tracker, we call them as master nodes. Name node, secondary name node, and job tracker, we call them as master nodes. So name node, secondary name node, I represent this as SNN, secondary name node, and job tracker. Now we call these 3 as master nodes, and the slave nodes are data node. Now data node and task tracker. Now here the architecture of Hadoop 1x version. These daemons belong to, we are discussing the architecture of 1x version, not the Gen 2 Hadoop architecture. We will be discussing about the Gen 2 architecture in the coming sessions. Now the architecture of 1x or Hadoop 1 architecture. So this is architecture of generation 1.x. So this is the architecture of Gen 1 architecture. So in this you have name node, secondary name node, data node, job tracker, and task tracker, and you have 3 master nodes. One is name node, secondary name node, and job tracker, and we will see what is each processor's role in dealing with Hadoop architecture. And the slaves are data node and task tracker. Data node and task tracker. So now here, another way of representing this is, we can call, when it comes to storage, and when it comes to processing or analyzing the data. Now when it comes to storage, as we know, HDFS, Hadoop Distributed File System, is for storage, and MapReduce is for processing. MapReduce is for processing. Now HDFS for storage, the supporting processors for storing the data are name node, secondary name node, and data node. When it comes to processing or when it comes to map reduce, now here comes the job tracker and task tracker. Once again, we are studying the architecture of generation 1 Hadoop, 1x version of Hadoop. So the architecture of 1x version is designed on a master and slave architecture, In this architecture, you have master and rest of the daemons or rest of the nodes can be called as slaves. Now here you will see whenever you start Hadoop on your cluster, you would see 5 processes being run, and those 5 are name node, secondary name node, data node, job tracker and task tracker. Now name node, secondary name node, job tracker, we call them as master nodes. Data node, task tracker, we call them as slave nodes. Storage nodes or HDFS nodes, name node, secondary name node, data node. Processing, when it comes to processing, that is map reduce, job tracker and task tracker. So here we would be thoroughly looking at what is a name node, what is a secondary name node, what is a data node, and how you can read the data or how you write the data on a cluster. In the earlier sessions, we have seen a concept called rack awareness. How if a client wants to read the data or write the data, what are the things that has to be taken care by the client or by the master node. Now this concept we call it as the rack awareness. So if I wanted to write any data onto the cluster or any data if I wanted to run, I need to looking at few of the characteristics which where rack awareness comes into picture. So before going that, we will be looking at what is name node. Now what is a name node? What is a name node? We call name node as a master node. Name node is a master node of the cluster. Name node is a master node of the cluster. And what are the hardware requirements? What are the prerequisites for the name node? Name node always has to be an expensive system or a server grade machine. Name node always has to be an expensive machine or a server grade machine. The reason why we have to, again it contradicts the statement that Hadoop can be installed on commodity hardware. Yes, but name node always has to be an expansive system and a server grade machine. The reason is name node is a master node. Name node is a master node. Always a master node has to be a system with good hardware requirements, or name node always has to be a strong system on a cluster or on a network. So name node always has to be a server grade machine. We call it as a server grade machine with dual power supply and latest level of RAM. So server grade machine, or we call it as expensive or reliable machine. Always master node has to be an expansive or reliable machine. So name node we call it as a master node, and it has to be a server grade machine or an expansive machine. Now what do a name node do in a master and slave architecture? As the name suggests, master have always command over the slaves. Master would always have the command over the slaves. That means master is the one who would direct all the slave nodes to perform certain things, so to take some actions. If anyone wants to read a file or anyone wanted to download a file onto the cluster, the client first has to contact with the master node, because master node is a node where it contains all the information about the nodes of the cluster. So here what we are saying is master node contains some information. That information we call it as metadata. We call it as, so master node contains the information that master node contains is metadata. Now, what is a metadata? Metadata is nothing but information about all the slaves, or we can also call it as data about the data. So, it does have the data about the remaining slaves. So, it has the data of the remaining slaves. So, master always stands first and it has all the control of the different name nodes on a cluster. So, master, that is the reason master node. So cluster can be, as we have seen, Yahoo has a cluster of 1000 nodes. So, master node, so how many nodes that we have, how many master nodes that we have to keep, we will be looking at all these things later. To understand the overall architecture of HDFS, so master and slave. So, master always contains the different information about the file. So, any data that you wanted to access, first you go to the master and data would be accessed. That means all the addresses, all the files information and all the permission level information, location of the block and size of the block, every information you will get from the master node. So, that is the reason we are supposed to have a very good system when it comes to installing a master node. So, master node has the metadata. Now, what is this metadata? So, master node has the metadata, and metadata consists of now we are saying that is one of the important characteristics that Hadoop architecture has, not the relational database model. So, any other the advantage of having Hadoop over other avenues or other platforms is that it has a concept of metadata. So, metadata is something, data about the data. Now, what are the contents of the metadata, or what does a metadata or what does a name node would contain? Contents of name node, or you call it as metadata, right. So, what does the name node would have? Name node would have information about the namespaces and the log files. We can also call it as transaction logs. So, whatever the data, now namespaces is nothing but name of the folder or the name of the file or the access level permissions, and whether it can be when a particular file is modified, or when a particular file is deleted, and what is the name of that file, in which directory that file exists, what is the size of the block for that particular file. So, all this information that you have in metadata. So, namespace is nothing but pertaining to the names of the files in the folders. So, log files is something, the transactional data, whatever you do on a cluster at this particular hour, some amount of data is being dumped on that particular cluster, or some amount of data is being deleted, or new information is added, or a new node, we call it as commission and decommissioning. Whenever you add or whenever you remove a node from a cluster, we call that process as commissioning and decommissioning. So, all this information that you have in log files. So, we'll be looking at a little more details about the log files and the metadata. To make you understand, master node has metadata, and metadata has two components in it called namespace and log files. So, that is the information about some details about the name node. So, now name node also acts as a single point of failure, though it is very reliable, though it is a level of server grade machine, but a name node is a single point of failure. Now, name node is a single point of failure. So, let us say I have a node here, I am calling it as a name node, and I have all the data nodes connected to my name node. Now, if you further increase this diagram, this is only one node. You can have any number of nodes that becomes becomes a rack. Here also any number of nodes. So, now geographically rack can be anywhere. So, pictorial representation, we are saying that here is a master node, these are the nodes that you have, but geographically a cluster can be on a different location. So, data nodes or the racks can be on a different locations, right. So data node, when you connect, now what I am saying is name node contains something called as metadata, okay, and these contains the data whatever we will upload. Now this, if name node fails, this process called as single point of failure, though that will not occur in any of the production environment. Always you have something called as disasters management. So what happens when something disasters happens to my cluster, that would be taken care by the administrators. Now this is a vague scenario where you will see a name node being done, but we call name node as a single point of failure. So what happens if that name node fails? What are the repercussions that you have on a cluster? Everything will be taken care by the Hadoop administrator on a production environment. So we don't have to be worried in any of the cases. Also we have seen the previous sessions what are the different situations that actually contribute for the failure of any of the node. So a name node generally can be due to the power failure, or due to network problem, or entirely that system goes down. There are certain things that actually contribute the failure of a system, but in production environment we don't have to be worried about no name node being failed, but we call it as a single point of failure. That's when, to overcome this problem, in this version of Hadoop we have something called as high availability. High availability. So that is introduced in Hadoop 2.x version or Gen 2 Hadoop. So remember, we will be looking at the architecture of 2x version as well. As of now, we will be only be looking at 1x version of architecture. So name node is a master node which is of the server grade or very expansive machine. Expansive, I mean to say any good processor of i7, but the RAM, when it comes to RAM, generally all the machines on a data node. So when I say commodity hardware, don't be confused that they are real cheap machines. No, they are not. Generally the laptops that we use, the modern laptops that we are using with i7 processor, and i7 processor with a RAM of 4 to 16 GB with a hard disk of 1 TB. These are the configuration requirements for a commodity hardware. So commodity hardware, when I say commodity, so commodity hardware, these are the configurations: i7 processor, 4 to 16 GB of RAM and 1 TB of hard disk capacity. Now when it comes to name node or a server grade machine, obviously a server is a more reliable, a more which has a more RAM installed and more kind of power supplies that you have for a, so that's the difference. So now name node is a expansive and it has got metadata. It carries something called as metadata. So what is metadata? Metadata is the information about all the slaves on a cluster. We call it as data about the data. Now what does this metadata consist of? Metadata consists of namespaces and log files. We call log files also the transaction logs. So what is a namespace? Namespace is name of the files, name of the folders where actually that file exists, and log files is whatever the actions that you do on a cluster. So we will be discussing about namespace and log files in the coming sessions. Right, now name node acts as a single point of failure, and to overcome that, in Gen 2x of Hadoop we have something called as high availability being introduced. So that is the brief discussion about name node. The next process that we will be talking about is the secondary name node. What is a secondary name node and what is the role of the secondary name node? Name node. Now this name node, we consider it as a name node. Again, we don't call it as a name node, we call it as a secondary name node. Now what is the role of the secondary name node is, now let us draw a diagram to understand this. Now this is my name node and these are my data nodes and connected to one single system, that is called as name node. Now this is my cluster, this is my cluster. Now there is one more daemon that we are talking about, is also a secondary name node. Now secondary name node is a standby for a name node, as we are saying that name node is a single point of failure. Now if something happens to a name node, now that information, whatever the information that you have on the name node, now again we have to understand what are the different information that you have, all the information about the cluster, all the information about the folders and the files that you have. So what does a name node do is, now here name node would have its information again in two places, one is the RAM and one is the hard disk, or one is the main memory. So okay, so hard disk and the main memory, or sorry, the RAM. So name node would have the information about the cluster on a RAM or on the hard disk. So now whatever the information that you have on the name node, whatever that information that you have on a main memory of the name node, what the secondary name node would do is, it will take a snapshot for every 1 hour. It would take a snapshot of the contents of the name node's main memory for every 1 hour. So what happens, what are the information that you have, every 1 hour SSN would take a snapshot and keep it to itself. So what happens is, so if something happens to the name node also, only you would have that 1 hour information lost, because let us say it has taken a snapshot at 10 a.m. and again it would go for a snapshot exactly at 11 a.m. Let us say 10:55 something happens to the name node and name node will not respond. So you don't have that 10 to 10:55 or 11 information on SNN, but before till 10 o'clock you will have all the information about the cluster on secondary name node. This is to avoid actually the single point of failure, but this was actually completely taken care on Hadoop 2x version. Now here, so SSN, now the secondary name node is not a replacement for the name node, is not a replacement, but it is something like a, you call it as a backup, you call it as a replacement, you call it as a standby. So name node, the role of secondary name node is to have a communication with the name node and to take a snapshot of the contents, whatever the contents that name node has about the cluster's information. So secondary name node, again it's an standby or a backup standby of the name node. And secondary name node is also expansive machine. It also has to be an expansive machine, and there is a communication happening between the name node and secondary name node. So anything, any cluster, HDFS cluster has a name node and also has a secondary name node. Secondary name node just stands like that. It will not interact with the data nodes. It will not interact with the map reduce architecture. No, it simply sits and takes the snapshot for every hour, what are the contents of the main memory of the name node. That is the brief introduction of a secondary name node. So next node is data node. Now in any cluster you would see, in any HDFS cluster you would see there is a name node, a secondary node and the data node. Now you would see we are saying that we have only one master node and rest are all data nodes. The question is, why so many data nodes that we need to have? The question is, why these many data nodes that we need to have? Again it takes us to the discussion of the basic use, the criteria of Hadoop is, why we want to have Hadoop is, we are dealing with not small files, we are dealing with huge amount of data with large files. So large amount of data on a single file. So if you wanted to have that data being maintained on a cluster, that is the only reason that you have, and this data is being scattered across the cluster. So that is the reason we need to have more number of data nodes. So data node is a place where you store the data can be stored, any form of data can be stored. Now we call them data node as slaves, and also we call them as the worker nodes. We also are worker nodes. You call also them worker nodes. These are inexpensive, any inexpensive or commodity hardware. So as I said, when I say commodity hardware, again, commodity hardware is not the entirely very cheap, very low level of configured system. No, commodity hardware can also be of 1 TB of hard disk with i7 or i5 processor with a RAM of 4 to 8 or 16 GB. So this is the basic configuration of a name node. This is the basic configuration of a data node. Data node. So data node's configuration is 1 TB i7 and or i5 processor with a RAM of 4 to 6 or 8 or 16 GB of RAM. So we are calling now data node is, now this is the commodity hardware. Now the data node is called as a slave node or a worker node, and it's very inexpensive, and that means the commodity, and the configuration, the hardware requirements or the hardware configuration of commodity is something like that. And data node would always be connected to a name node. So connected to a name node. Now always there will be a communication happening between the name node and the data node. There will be a communication happening between name node and data node for every 3 seconds. Remember, every 3 seconds there will be a communication happening between the name node and data node. We call it as heartbeat. Heartbeat. Yes, heartbeat. That means data node says that I am alive. So every 3 seconds you have that communication being happening between the name node and data node. We call it as heartbeat. So remember the term heartbeat. Now that's the brief introduction of the data node. So how the data is being stored and how the processing would be done, we'll be looking at that. So now overall in Hadoop architecture, we have 5 processes running in 1.x version of Hadoop. Those 5 processes are name node, secondary name node, data node, and we have not come yet to what is a job tracker and what is a task tracker. We will be looking at those also. So these are the 5 different or 3 different processes when it comes to storing the data. When it comes to processing, again we have a MapReduce architecture. At that time we would be discussing about what is a job tracker and what is a task tracker, right.